After completion of this video, you'll be able to explain the role of BIM during the construction and handover stages, describe how the common data environment transitions through the project lifecycle, explain what a digital twin is and its role in operational efficiency, describe the impact of BIM on cost and reducing time on site, and identify key documentation produced during this stage. The transition from the digital model to the physical asset happens during the construction phase, where as a result of the meticulous planning and coordination from the previous stages, time and cost savings can be measured through accurate and efficient execution on site. In a BIM project, designers can use other disciplines' 3D models to help them design their own task, such as here, the MEP or Building Services Design team are using the structural team's model to find coordination issues, such as where the building services may clash with the structure when being constructed. This would cause an obvious problem if someone turned up on the construction site to install these pipes and other services, and if they can't install them as the structural frame is in the way, this would lead to delays and possibly additional costs. Instead, the teams use these models so that they can position the services in a better location and ensure when on site there will be no issues installing them. The BIM model is not discarded now that construction has started. As work progresses on site, the 3D BIM model is continually updated with any changes to the physical asset, such as alterations to pipework location, even just millimetres out of place, can have an impact on future use of the digital and physical asset. One powerful application of technology during this stage is the use of 3D point cloud scans, which are used to compare the physical built asset with the digital model. This ensures alignment with the design and allows for real-time updates to the model, keeping it accurate and relevant as construction progresses, so that when handover comes, the digital model supplied to the client is an accurate model of the actual built asset. The construction phase relies heavily on the collaboration between on-site and office-based teams. Real-time updates are essential to maintaining alignment with the program plan. 3D point cloud scans of the progress on site, as well as other tools used by the design team to plan the program schedule, can visualize the construction progress and identify potential bottlenecks in the construction phase and ensure important milestones or dates that work packages must be completed by are met. Tools like Navisworks Timeliner and 3D point cloud scans of the asset visualize 4D simulations that link the BIM model to construction schedules, and the point cloud scans allow teams to monitor actual progress on site against the schedule. This information, in the form of point cloud models, schedules, and progress reports, are shared on the CDE for all teams to access. Now let's look at the handover phase, which is the stage in the project where all of the relevant documentation, 3D models, and data are transferred from the construction team to the client or facilities management team. And this handover of information ensures that the completed asset can be efficiently operated, maintained, and managed throughout its life cycle. In the early stages of a BIM project, the common data environment was set up. Stakeholders given permission to access specific areas, upload or download files. This centralized space is updated throughout the construction stage with all of the files needed to design and construct the asset. This doesn't end after the construction of the building. Imagine being handed the keys to a new building without training on heating or security systems, and in time, maybe you'll need to replace a door. How would you find an exact copy? During the handover, the common data environment transitions from being a collaboration and design management tool to a central repository for the as-built data and asset information. The up-to-date or as-built BIM model evolves into a digital twin, a comprehensive repository of data for the client of all of the constructed elements in the building, including information such as manufacturer, product numbers, warranty information and contact details for the suppliers, all organised so that it is easily accessible by the client. And throughout the project, when systems are confirmed, such as the type of heating or security system, the relevant client teams can receive training so that when handover does come, they know how to operate the building. Facility managers can use this digital twin to schedule maintenance, monitor sustainability outcomes, and achievement of high-level goals such as reduced energy and water use. Key documentation that's handed over at this stage include the as-built BIM model or digital twin, the operation and maintenance manuals, which would be the instructions for the use and upkeep of the building systems, and any handover or soft landing plans, outlining the transition from construction to operation, including training and support for any facility managers. From defining project goals in the early stages through concept design, technical development and pre-construction, to construction and eventual handover, you now have a better understanding of the BIM process and how it provides a clear and interconnected roadmap for project success.